Let's look at the solution to our second write update versus write invalidate quiz. This time we have a program where one core repeatedly reads and then writes A, and then the other. So how many bus uses do we get with the write update and with the write invalidate protocol? This time the write update protocol is going to have one bus access here to read because this is a miss. Because there is no sharing, the write doesn't need a write access, because we know that we privately have this thing in our cache. So this is what happens the first time. In the remaining 499 iterations of this, nothing else happens. We just hit in our cache. Once we get to core 1, however, the read A is going to get the data from core 0, but now we have the shared bit set at 1 in both caches. So the write here will need to do a broadcast the first time, and then the next time, and so on. So overall, we get 1 for the initial miss, and then 500 updates of core 0's cache. Note that this is wasteful because core 0 is no longer really interested in this. So overall, we get 502 bus accesses. In a write invalidate protocol, we have the same thing here. We have a miss, and the data is not shared, so the write and all of the reads and writes after that are just cache hits. However, here what happens is the read here will make the data shared and fetch the data from the other core, so that's going to be a miss. Because the data is shared, the write will have to do an invalidation broadcast, so we will have another bus access, but that makes the data private to core 1 now because this version is invalidated. So for the remaining 499 iterations of this, nothing else happens. So overall, we get only 3 bus accesses. As you can see, write invalidate is a lot more efficient if data tends to be used frequently on one core and then the frequent use moves to another core.